Hey guys, welcome to the second part of Beginner Introduction to SQL and Databases. So if you take the first course, you know that the prerequisites are pretty low. We'll need a GUI, basically Beekeeper Studio, which is free and we used in the last video or the last lesson, is still available and still recommended, or you can use anything else you like, such as DataGrip or any other UI of choice. Of course, you will need an internet connection. We will be connecting to an online database, so we'll need that connection. We do have the connection properties listed in this slide, so take a moment to pause the video, write them down if you like, or enter them into your GUI, and you'll be able to connect quickly, and then we'll get started. We will be covering a couple of things as quickly as possible in this 2-hour video. We'll be profiling our data. We'll be looking at the group by statement. We'll also look at string manipulation, which is probably one of the more fun and interesting things that you can do with SQL, in my opinion. Then, of course, we'll cover subqueries, case statements, and try to focus all of our remaining time on joins, since joins will be your bread and butter as you evolve or go into your analyst career. Great. Well, thank you very much for taking the time to check out this course, and I'll see you in the next video. Hey guys, welcome back. We want to start off with launching our Beekeeper Studio and connecting to our database. If you were here for the first course, you'll recall that we set up our connections. All I have to do now is to actually just click on my connection, click connect, and that will take me to my database. If you're not familiar with this, take a moment to maybe either review the first course or set up your connection using the connection properties provided in the last video. You may recall we have 2 databases available to us, OscarVal_SQL course and OscarVal_DDL sandbox. We will be doing the majority of the work in this course in OscarVal_SQL course and working with the IMDb movies table. So now that I've connected here, you should have the same screen. I want to talk about data profiling. So the first thing that I want to do is actually expand the table IMDb movies and quickly take a look at these right-hand columns, or these right-hand values, excuse me. I'll notice that I'll have listed here or noted here that certain fields are varchar, right, followed by a number, and that number depicts the length. It's actually varchar is telling me that this field contains string or text information, and it's like 51 characters in length. Then I'll have other fields that will note or that'll have int next to them, and even decimal. And so int and decimal are numeric fields, so they'll have numeric only values, and these are the fields that we can apply aggregations to, such as sum and average, and the aggregations that make sense to numeric fields only and not necessarily string fields. So let's go ahead and sample or take a look at the first 100 rows in our data and begin to profile it a little bit more. So I'll highlight that, hit Control Enter, and then get 100 records. So as you see here, the first field that that's of int value, that's an integer value, is just that. It's a number field consisting of the year that the movie was published, and these are all numeric values. So we can actually do some sort of numeric aggregation with these fields, or some sort of arithmetic or what have you. Most of the fields are string fields, with some going as high as 273 strings in length, being maybe like the list of actors, which makes sense, or the description of the movie. So as I scroll through here, I want to take a look at a couple of peculiarities, right? One is the country. Now, typically when you think of a movie, you'll associate one country to the movie, but immediately we want to see, like, within our first 10 records or so, we see that some movies have actually more than one country associated with them, and it's actually represented here by a comma. So you'll have the first country, comma, second country, and so on. And this is kind of important to note, because when you're dealing with your data, sometimes your questions will be very specific, that you'll have to understand how your data is recorded and start accounting for the nuance. So if someone told you to give you a count of all movies made in the USA, you would have to find a way to account for this movie that's made both in France and the USA, if you wanted to count this movie as a movie made in the USA. So that's one of the profiling exercises, just really kind of going through your data and just taking notes of like little nuances and discrepancies. Another one here that we see is budget. Now, budget is really the cost to make a movie. So if we start noticing here, we see some peculiarities here. One, if we look back to the data type that it's a varchar or a string, and budget really is a cost, right, or a value. So the reason it's noted or listed as a string or a varchar is because we see that our values are prefixed with currency figures, such as maybe, let's say this is dollars, and this is maybe like the Italian currency, and so on. So we start seeing that these currency markers are factoring into whether as to like why budget, the budget column itself, is not a strictly numeric value, but it's a string value. Next, I also want to take a look at something a little more peculiar, in these two sets of differing null values. Now, null in database terms means nothing, emptiness, right? There's like absolutely nothing there, and those are different from a blank. So a blank would be select and then maybe two single quotes together back to back, just absolutely like there's nothing there. It's a blank, right? But it's still taking up character space. So if I execute that, Beekeeper Studio actually gives me this pretty empty, pretty peculiar message, calling it a null. Well, it's not really a null. It's just a blank. And for Beekeeper Studio, I want to say this is a little misleading. It should really just have a blank space, or not even really say null, because a true null means that there is nothing there. So when I go and I select null on its own, it'll actually give me this little grayed out uppercase spelling of null in a little in parentheses. So null in its true form is absolute emptiness or nothingness. And I want to illustrate how to query for each, or like the distinction. So I'm going to go back to a couple of columns. The columns with a different type of nulls, right? And like again, I'm saying these nulls are blanks, and I'm going to query for those, right? So I'm going to say select all from IMDb movies where budget is null. Now, if I were to say that, I would be asking for records where budget is actually null or empty. Let's see if we have any such records. No, we don't. No results. Now, if I were to change this where budget is blank, meaning it has like records with like literally the blank character in them, then I get back some records. And that's because there's a distinction between a null and a blank. So these are actually blank records, and then these are truly null where there's nothing there. So I'm going to do the same thing, but for USA gross income instead of budget. So say USA gross income where it's blank. Run that, there are no results. But if I change it to is null and run that, then I get back some records. So the USA gross income itself, it truly does have null values, meaning values where there is absolutely no data, no blanks in there, no characters, not taking up any space. These are the true empty records. And it's important to note, now and the reason I'm calling this out over and over is because in other databases, if you have nulls within numeric values, many times you have to do something with the nulls so that they are handled in a way that they don't interfere with your calculations. Nulls can throw your calculations off by omitting records or inferring values that don't exist, or just overall throwing off the calculation. So sometimes you have to set them to 0 or exclude them altogether, or or whatever the case may be. So I wanted to draw that that distinction. So I'm going to wrap it up there, because I know this was a pretty long lesson of just kind of talking about the data. But data profiling, though, it is important, and I want to make sure that I took an adequate amount of time to kind of talk about and walk through some of the nuances in our data. Again, when field is supposed to be numeric, but it's not, there could be some reasons why for that. So, such as like the currency description, again, the differences between nulls and blanks, and then, just what to expect in your data. If you're giving a question that's country specific, it's good to understand that, hey, there are some movies that have more than one country associated. So start thinking about how you're going to deal with that. All right, well, I'll leave it there. Thank you very much for sitting through this video regarding data profiling. There's more fun to come, a lot more hands-on SQL. So I'll see you in the next video. Hello and welcome back. All right, so let's get started with group by. And group by is the perfect place to continue us from the last course onto this next course. The reason I say so is because in the last few videos in the first course, we talked about some aggregation functions such as min and max, and we're going to introduce a couple more along with the group by and try to get an understanding of what that means. So if I look at my data, I know that we have a couple of numeric values in here. As I mentioned earlier, duration is one of them. It's an integer value. Year, it's an integer, and votes, and a couple of more. So if I ask the question, give me the average movie duration, like how long movie was, or how long movie ran for, by country, I can start typing, select country, average, and I'll type duration as average duration, alias the column, from IMDb movies. Now, one thing that I'll have to do though is actually start grouping my data. And while MySQL may not necessarily give you an error, other databases will. So, and it might, and even if it doesn't give you an error, it might give you just some weird results. So it's important that whenever we're issuing an aggregation function and we're grouping it by something, right? We're breaking it out rather by a field, that we group that field or fields that we're breaking it out by right back here in the bottom. So we would type group by, and we have two options. We can actually say country, so list the field again, or we can include an ordinal value. So since we're only grouping by one column, we can just type the 1. So I'll type country, and we'll try other variations later on, and then you can just determine what you want to do. But let's go ahead and run this for now. So hit Control Enter, and now what I start seeing is that I get pretty much, this is in alphabetical order, but I'll get like the average movie duration by country. And as we saw earlier, we have some movies that will have more than one country associated with it, but we'll have like Albania at an average of 98 minutes per movie, Algeria at an average of 113, and so on and so forth. Now, if we feel that some of the country or multi-country movies are a little bit of noise, we can always use our not like operator to start canceling out some of that noise. So we'll say we're country not like, and basically we're going to exclude any movie that has multiple countries by looking for that comma. And so we'll put a wildcard character, comma, wildcard character, and then enclose it in our single quotes. And so basically we're saying where a country is surrounded by characters and has a comma, let's go ahead and omit those. So we'll run that, and we'll get a much cleaner list. And we start seeing that we have a list of single countries, right? And their actual movie duration. So if we wanted to maybe search for France, we can just kind of skip down and look for it, and it's just a lot cleaner, right? So we have a 99 minute average. If we want to also employ our order by and maybe look at like a list or rank them, by the longest average duration, we'll just say order by 2. This is where we can actually start using an order of value, and we'll type descending, right? DESC for descending, and so basically it will give us in ranked value by highest to lowest. So we'll run that, and here we go. So Ethiopia actually has the longest average in terms of movie duration, followed by India, and so on. So you can see that here. All right. So for your exercise, let's see if you can get the average duration by language this time. So let's check that out. Okay. So the next exercise, as we mentioned, we are going to try to get the average duration by language. And we can actually copy and paste this code that we have here. And let me do something. Let me actually increase the screen size of this by typing Control+. It's a little big, but I think that's fine. That's adequate, not too big. And so we'll start looking for language, right? So we know that we have a field here, language. So I'll replace country with language and group by language, and then we will run this, and now we start seeing that hey, we actually see that some movies have more than one language spoken in them, which really isn't surprising. We have, I'm sure, we've caught movies that have multiple languages spoken. One that comes to mind is Inglourious Basterds. I think they traded off from speaking German, French, and English in that movie. So maybe this country not like having the comma in there, where we're excluding movies with multiple countries associated. But we'll do a language. This time we'll do that language exclusion. And instead of saying group by language, here I'm going to use my ordinal value and just say 1. And just go ahead and run that. Here we go. Now I get a good sense of like movies where just one language was spoken throughout that movie and what the average duration was. And I start seeing Maltese, Filipino, and so on. Are the types of movies that have the greatest duration by language, right? Like how long they actually lasted when you start averaging them all together. So that was pretty simple. Now let's say, for example, I want to do one more thing with this group by, and I want to start, and I want to say, maybe I want to look for a range, right? I don't want to necessarily, go so low, or I'm not interested in, movies that are under 110 minutes, but I want to look at things that are, and then I don't want to look at movies that are above 140 minutes. So I want to kind of basically have a filter or range. What I'm going to do is I'm going to introduce my having, and basically I'm going to take the function that I'm using, my arithmetic function, and I'm say having average duration, and now I can set a parameter, right? And I can say between, let's say 100 and 135. So now I'm saying give me a list of languages where when you combine the average duration, it's between 100 and 135. And this is just, and I'm only going to cover it here because you're probably not going to use it too often, but having really works as a filter for your group by clause or for your aggregate clause. So I just want to briefly introduce it, and let's go and run and see what that looks like. So here what we've done is we've actually eliminated the results where the average movie duration for that country was either greater than 135, right? So we don't see anything over 135, or less than 100. So this one is 100.4, so it's still over 100, but we won't get anything smaller than that. So we've done that effectively. All right, well, thanks. There was a kind of an extra little tidbit there. Don't worry too much about the having. The focus is on group by, but I did want to just introduce the having in there because it does act as an effective filter for the aggregation that we're doing. Thank you for watching, and I'll see you in the next video. Okay, the next topic that I want to talk about is the function of summing. And so if you recall from our last conversation, summing is basically totaling a specific column. And as we know from our data types, there are only a few columns that we can total. Again, we'll make duration our main focus. And what we want to do is we want to identify maybe like the top 5 directors that have the most movie minutes, right? So let's go ahead and say select director, comma, and duration from IMDb movies. And again, we want to actually total all the movie durations per director. And we're going to call this, we're going to enclose this in sum, in the sum function. Say sum duration as total duration. And again, we're going to group it by the field that we're actually breaking out the data by. So I'm going to use 1 just for simplicity, since it's like the first, since there's only one kind of grouping column that I'm using. So I'm going to type group by 1. Group by 1. And then we will order by 2, by the second column, by the second ordinal column. And we'll order in descending order, right? From greatest to least, or to smallest. And we'll also limit it to the first 5 records. And so this will give me the first 5 directors that have the most total movie minutes combined, in directing from this movie data set or this movie table. So let's go ahead and select all, run this, and we see that Michael Curtis has directed a total of 8,312 minutes, at least in this data set. Now remember, in our data profiling, we kind of looked out for some wonky data, and one of them was being nulls or blanks. So we see here that there are some movies that don't have director associated with it, so that really isn't a valid record. And so that's where that data profiling comes into play, and we know that that particular record has, or those records, have no value, no real value. So we're going to say where director is not equal to blank. And so we'll run this again, and then here we get the list of the 5 directors with the most movie minutes to their name. So great. Yeah, hopefully that was easy. Now I want to go ahead and do the same, but this time I want you to take a look at the top 5 individual country with the most movie votes. So think about what that means in terms of which records you'd include or exclude rather, and then using the sum function of which fields you'd use to get that information. So I'll see you in the next video. Okay, so what we're going to find in this video is we're actually going to take a look at the top 5 individual countries with the most movie votes. So we know that we want country, that is one field, and we want to sum votes, right? So we know we have a column called votes here, and we will call these total votes. And again, we'll group by, I'm gonna just spell it out this time, say group by country, and I'll order by 2 descending, since we're looking for the most votes, and I'll limit it again by 5, right? Now, if I recall from our data last time, one movie can have multiple countries associated to it, so this is completely optional, but it's probably pretty clean to just say where country is not like, and we'll apply some wildcard characters and exclude any country list, or country value that has more than one country associated with it by excluding anything that has a comma. And this should be Actually, it should give us what we need. So let's go ahead and highlight and run that. Here we are. So now we see that the top 5 countries with the most movie votes are US, UK, India, Japan, and France. So that was it. Pretty easy peasy. All right. Thank you very much. I'll see you in the next video. Hey guys, welcome back. All right, now we're going to move on to our next section where we're going to talk about string manipulation. Go ahead and clear your query window. Unless you decided to save your queries, then go ahead and save your queries. Let's go ahead and start by taking a look one more time at a sample of our database. So I'm going to take a look at the first 100 records. Okay, so the first string manipulation that I want to talk about is actually the trim function. So here it's very difficult to see if these string values themselves have any white space. So I'm not going to necessarily demonstrate the trim function on a column, but I'm going to demonstrate it on a string itself. So let's go ahead and type select and then say this is a movie title. Okay, and then we'll highlight that, hit Control Enter, and we see it says this is a movie title. And I'll go ahead and alias it as title and just run that one more time. And so here's like the column name, right, that I'm aliasing as title, and then this is the movie title. You see that there is no white space here, right? Now what I'm going to do is I'm going to introduce quite a bit of white space in the front, and so it should be pretty visible, from this output result to this next one. So I run that, and you see that I have like this white space right here, and I can do the same to the right side of it and add some more white space. Now that right side white space will probably be difficult to see, but let's go ahead and run that anyway. Okay, so what I've done here is I created this string with a white space, and sometimes you might have white space within your data. So one of the things that you can do to deal with this unwanted white space is actually invoke the trim function. So I would say trim and then move my parentheses at the end. So now I'm encapsulating this column, right, of data, single row, single column of data, and I'll go ahead and highlight that, Control Enter, and as you can see here, it's actually removed my white space both in my left and my right side. You can actually just remove it on one side, so you can type rtrim to delete the white space from the right side only and leave the left white space. So you see we're left with the left white space, or we can do that for the left and leave it for the right. So by typing ltrim, L being for left trim, and we'll run that, and we see that we eliminate the white space. But just for conciseness, you never really want to leave white space anyway, so you can just leave it as trim, and that is how you get rid of white space. Cool, that was short and sweet. Let's go ahead and actually move on to our next topic. So see you in the next video. Alrighty, welcome back. The next function that I want to talk about is substring. Now substring is pretty interesting. We'll go ahead and look at this and then try an exercise. Let's go ahead and bring in the title one more time, and we'll just take a look at 100 movie titles. So let's go ahead and run that. Now substring, okay, is in some databases can be written out entirely substring, or you can type substr, and really what you're going to pass is the column name, the starting point where you want to start. So like how many strings into the title do I want to start counting from. So if I want to start counting on the second string where it says where it has the H, I'm going to type 2, and then the number of strings that you want to count, right? So let's say maybe you want to count 5 strings over, or let's just say 10. We'll start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so we should stop like at like key story. That's what like the first record would say. So so substring is essentially returning a substring with a start and stop point for the string that you're trying to get the fraction of, or the substring for. So I'm going to call this sub str title and run that. Okay, so here we go. When we start at the second string for the title of the story of Kelly Gang, then we basically just get he story O, right? And that's 10 characters total. So it's actually pretty neat whenever you want to extract, maybe a piece of a smaller text from a larger piece of text, right? If you know exactly kind of where it's at, then you can totally do that. So what I want to do is I want to challenge you, right? I want us to look at date published, and using the substring function, knowing that movie title is obviously very random, and it would be very difficult to extract like words from that substring just by placement alone. But if we look at date published, we do see a consistent pattern. So I want you to use date published and substring on date published and extract the month. So go ahead and take a minute to try that out, and we'll see you in the next video. Okay, welcome back. So what we said we're going to do is we're going to extract month from date published. So what I'm going to type is select date published, right, just to kind of have my comparison point. And then I'm going to use a substring, and again the field I'm going to parse, which is actually a string field in this case, is date published. And if I want to extract the month, the starting point for the month is actually the 6th character. So if you look at 1911-08-19, you have the first character, second, third, fourth, fifth is the dash, and 6th is when the month actually starts. So I want to start on my 6th character, at my 6th character position, move 2 over, right, grab the next 2 characters starting at that point, and then that will give me my month. So I'll type from IMDb movies, limit 100, and now I'll be able to compare the date published and the month from my data. And I'll just bring in title just to kind of have a little more complete data here. Alright, so here we go. Now we have obviously the movie title at the date published, and we were able to beautifully extract month for all these columns except this one. Notice that this one didn't have a month, so it just kind of gave us a blank in this case, but it said but basically we're able to successfully extract month from each of the dates that had the month, and now we have that as a value. All right, well, great job. Hope you got that. Hopefully it was pretty easy. I'll see you in the next video. All right, welcome back. Next I want to talk about the lower and upper function. So we'll go ahead and run through an exercise using the lower function and see what it does, and then we'll hand over an exercise for you to try out on your own. Okay, so we'll start with lower, and let's go ahead and look at title. Okay, so I'll say select title from IMDb movies, and as you can see here, we have basically a varied case movie titles where the first letters are typically capitalized, and if I want to convert all these letters to lowercase, I can actually just type lower and I'll alias that as lower title. And so when I run that, right, and I'll also include title here so we can compare. If I run that, I see that all my words are now lowercase, right? Regardless of where they are in the sentence, are all lowercase. So that's pretty straightforward. Take a moment, and I want you to do the same, but I want you to convert all the letters into uppercase. So if we use lower for lowercase, I'll leave it to your deduction skills to find the proper function and convert all the letters to uppercase. Okay, welcome back. Hopefully it was pretty easy and kind of easy to deduce. If we're looking for upper, we are going to use the upper keyword, right? And that's also a function in SQL. So we'll say upper, and then in parentheses title, and I'll just call it upper title, just to distinguish. Go ahead and highlight my statement and run that. And now I see the difference between lower and upper being just that, right? If I invoke the function upper, then all my letters are uppercase, as opposed to when I did lower, where all my letters were converted to lowercase. So this can be useful when maybe you want to enter or convert some codes that are in lowercase into all uppercase, so that they're easy to read, like in reports or something. You'll use it. I mean, it'll be used on a case-by-case basis. I don't think it's used that often, but nevertheless, if you're looking at, let's say, for example, postal codes, and it's a human entered, kind of value where it's entered into your database, and it just varies. Let's say maybe some Canadian postal codes, folks will put lowercase letters and others uppercase letters, or whether it's names or emails or something, and you just kind of want to have consistency in the lettering and the casing for your reporting or analysis. That's when upper and lower come into play. So anyways, thank you very much for watching the video, and I will see you in the next one. Okay, in our next video, we're going to cover some functions that are very similar to lower and upper. And when I say similar, actually I mean they're similar in the sense that they don't necessarily get used as often, but they're good to know that they exist. And those functions are the lpad, that stands for left padding, and rpad for right padding. So essentially what they do, and it's probably easy to show you, is they'll pad the left side of the string with the character that you tell it to, or they'll pad the right side of the string with the character that you tell it to. So let's go ahead and type lpad title, and we want to pad it up to 30 characters, right? With the comma, with the asterisk. Okay, so we'll call this L title, and we'll run this. Okay, and so what's going on here is that it's going to pad, lpad is going to basically pad the title with asterisks up to 30 characters. So whatever number of characters the title doesn't take up, right? If it doesn't take up the whole 30 characters, then it'll pad anything that's up to 30 characters with an asterisk. So you'll see that for this really long movie title here, where it's only actually showing us up to the movie title, up to the 30 characters. But in these really long titles, they're not going to have an asterisk, so we're really going to have to go to like this the smaller, or I guess the shorter movie titles, so that we can start seeing some of that padding. And that's what that does, right? It'll introduce a padding up to this amount of characters for anything that is under 30 characters, and again for anything that's 30 or over, it'll begin to omit the asterisk and just display up to 30 characters of the movie title's name. So the same thing can be done using rpad, and as you probably guessed, that's actually going to do it for the right side. So this time we'll go up to 40, and we'll use a pattern this time. Maybe we'll do $% caret, right? Then we'll call this our title, and we'll see the difference here. Oops, I forgot my parentheses to close it. Alright, here we are. And as you can see here, it starts padding the right side with the series of characters that that we listed on the right side here, unless of course the title itself is 30 or in this case 40 or greater characters in length. So that's pretty much it. The use case for this really is if you have like a monospaced font where all the letter spacing is of equal width, and maybe you want to pad it with spaces so that you can have like an accounting report that's evenly spaced. You can totally do that or try to control it with SQL. Now that doesn't really happen much in modern times, but if you needed to do that, that is really what it's there for. So anyways, thank you very much for watching. I hope that was pretty straightforward, and see you in the next video. Okay guys, welcome back. In this next video, we're going to cover the reverse function. The reverse function, just like all the other functions that we've been running in these past few videos, manipulates string information, string or text columns, or as we see here on our left hand side, the varchar columns. And at first glance, this function may not seem all too special and a little weird, to be honest. Let's just take a look at what it does. So I'm going to use title once again, and then I'm going to apply my reverse function to title. So in my first column, I'm going to select title. The second one, it's going to be reverse title, and I'll alias that as reverse title from IMDb movies, and we'll limit that to 100 records. So let's run that. So it's probably very easy to see what's going on here. This string is actually reversed. So if you see the title displays just as the movie title would, when I apply the reverse function, the title actually just transposes, right? So like now we have the at the very end, but like spelled backwards, story of the Kelly gang, right? And so on. So you can kind of see that that is all that the reverse function does, and we'll make use of it a little later in the course. Actually, you'll make use of it in an exercise later. So keep this in the back of your mind. Very simple function, a little peculiar at first, but we'll see you in the next video. Thanks for watching. Alright, hello and welcome back. The last function that I want to talk about, or that I want to introduce, is the concat function, right? Or concatenate, as you may have heard it, maybe like in Excel or just like in normal talk when you're talking about stitching two things together. So this concatenate function is very simple to use, and it's pretty straightforward. I want to maybe select title and year, right? And what I'm going to do here in this example is I'm going to put together the title of the movie and then the year that it was released. So I'm going to say select title, year from IMDb movies, and limit 100. And I'll run that. And so my output, what I want to do in my output, I want to say maybe have like title, a colon, and then the actual year, of the movie. So what I'm going to use is concat, and then I'll type title, comma, and then in the single quotes I'll put a colon, space, and then enclose the single quotes or close out the single quotes, and then I'll type year, right? This is the other thing that I'm going to concatenate. And then I'll close this, and I'll just call this movie year, right? So let's go ahead and highlight that query and then run it. And so now we see that I was able to take two pieces of information and string them together to give me kind of like a title, right? Or some sort of information, some concatenated type of information. And this is useful, for a couple of purposes. Mainly if you want to churn out some report with some values and just kind of combine pieces of information together into one column, or maybe you want to combine two columns to kind of create a unique key, right? Maybe it's the the year of the movie and the title name, and that's unique in case movie were to share the same title across multiple years, but what keeps it unique is being published in a different year. So there's all sorts of use cases that you can use concat. What I want you to do though is I want you to for this exercise, or for your exercise, excuse me, is I want you to provide me a column that tells me the number of votes for a movie, right? So you'll be using the votes column, and then and it's a piece of string or a text that says number of votes, and then you'll pass in votes, and then you'll say average votes, right? And then you'll pass in this number of average vote, and and have it all appear in one column, so it's kind of like it reads like a statistic of a movie. So you can go ahead and delete some of these columns if you want to, or just append it at the very end. It's up to you if you want to just reuse this query. Take a moment to think about that and write the query for it, and I'll see you in the next video. Okay, welcome back. I'm going to clear out a little bit of my screen here just so I can have a cleaner canvas to work off of. So what I said, or what I asked earlier, was to provide basically some stats on the movie when it comes to votes. So I'm going to start with votes. So I'll say concat, and then in a single quote, I'll put number of votes, colon, and then close it with a single quote. Then I'll go comma, and I'll bring in the votes column, right, the votes field, and then in a new string, I'll probably put a space just so that the formatting could be a little cleaner and easier to read, and I'll type average votes, colon again, give it a space for formatting, and then enclose that single quote, and then another comma, and then I'm going to bring in the average votes column, right? And I'll call this movie stats, just for simplicity. And so like now I'm going to run this information. Oops, actually it should be average vote, not average votes. So let's go ahead and run that again. Now I have a descriptive column here. You can see that I have the string number of votes, right, as my first part, and then concatenated with the actual votes value, which is here, and then the average votes, and then the average vote value, which is brought right here. So that is one way to kind of just bring information together, for reports, for descriptive purposes, and kind of just have a clean reading pieces of information. And like I said, there's multiple uses for concat, as I mentioned in the last video. So, use your creativity, use concat as you see fit, and have fun with it. All right, so I'm going to stop right there. In the next video, I'm just going to give you a final exercise that's going to kind of involve the use of a couple of functions, a comprehensive use of the function. So look out for the next video, challenge yourself, and thanks for watching. Hey guys, welcome back. So in this last video, I want to take a time to just define the exercise of what we're trying to do. Essentially, we are going to isolate the last word of the movie title. So if we have let's say this first title, right, the story of Kelly Gang, we want to just come back with the result of gang. As you notice, there are some movies that are just made up of one word, like Cleopatra. In cases like this, we will return back Cleopatra. But in cases where it's two or more words, we'll actually just go at the end of the last word, and the last word will be defined by the last continuous group of letters before, or right after the last space, and then this is the last word. So in this example, guillotine is the last word, home, fantôme, and guerre, those would be the last words that we want to capture, right? So take a moment to kind of think about, like, well, where do I start, right? And you know what? I'm actually going to give you a hint. And by giving you a hint, I'm going to tell you which functions you're going to use, okay? So, hint. The functions to use are going to be reverse, okay? locate, and concat. Okay, so you're going to use these three functions to be able to achieve that. So give yourself some time to kind of think about how you would do that, and don't necessarily focus on the functions and try to piece that information together. Just think logically, with some of the things, the tools that you've learned, how you would, achieve, maybe the first part, right? Well, how do I isolate this first term? What exactly would I have to do in order to isolate this this very last term, the very last word, and then we'll go from there. All right. Thanks for just kind of going through this exercise and expanding your learning, and I'll see you in the next video. Hey, welcome back. In this section, where it's going to be pretty brief because the concept that I'm going to introduce next is pretty straightforward. The concept being subqueries. So let's talk about what a subquery is. Subquery basically is a query that is encapsulated to be used as a result set. And so that's probably a lot of words that may sound a little ambiguous, so let's take a look at what that is. So let's say, for example, I want to compute my average duration, movie duration, based on genre. And so I'll say select genre, average duration as average duration, and maybe I want to get max movie duration by genre as well, to have that as another statistic. So I'll say max duration from IMDb movies, group by 1, and I run that, and now what I have is for every genre that exists, I'll have what the average movie duration is, and then what the longest movie duration was for a movie in that genre. So that is a base set of information that I have. I can use that result set, as is, or if I wanted to, maybe use this result set and then start filtering on genre alone, I would enclose it in or make it a subquery basically. And the way I do that is by saying select all from, and then I'll start off with a parentheses, and I'm just going to highlight this and tab it over just for formatting purposes. And so you notice how I have the parentheses, the starting parentheses here, and I'm going to close the parentheses over here and basically encapsulate that query and that result set in this parentheses, right? And then now I'm going to alias this parentheses, and as I alias it, right, I can say T or table 1, however I want to do it. So I'll just say T for simplicity. What this is doing is basically it's treating the results of this query as a table. So like now when I say select all from this table, that's a result of my of this query or subquery. I'm saying select all from this result set and alias it as T. And you need this alias so that the SQL engine can identify what you're trying to do. So I'm going to run that, and what I get is the exact same thing that I saw before. However, now if I want to say, maybe add some conditions to it and say where genre equals action, right? Or actually I could say like action, so I can get more result sets. I can do just that, just start filtering wherever the action comes into play in terms of the genre, and then maybe I want to add like an additional filtered result set and say and average duration less than 90. So we don't want like too long of a movies. And so like now I have the genres where the average duration is not too long, and I kind of get a sense of what that looks like in terms of genre or at a genre level. So with the subquery, you're basically turning in the results of a query into a temporary table, and you're using the result set as something that you would query and apply maybe additional functions on top of that, If I wanted to, I can sum these values or average them again, or as I'm doing here, filtering based on genre, and so on and so forth. So it's a pretty straightforward concept. If you just think about enclosing your queries here and then aliasing that and treating it as a table. So I want you to take a moment. We're going to do a couple of exercises here. Go ahead and create a subquery for average and max duration by language. And I'll see you in the next video. Okay, welcome back. All right, so in this next exercise, the instructions were to create a subquery. We have average and max duration by language. This is pretty straightforward. I deleted my where and and clauses, and I'm just going to reuse this query and just change one thing, and that's going to be language. So if I run that, now I have the average and max duration by movie language. And as we know, some of these movies have multiple languages, so you'll have like commas in here, and same applies. We can go ahead and filter that where language, let's say equals, and want just Arabic only movies, right? Where the language is Arabic, we isolate that single record, and we kind of get, and when we can use like the result set and query it itself and apply additional kind of parameters to get like what we're needing from the data itself. But in a nutshell, though, the subquery that you needed to write was very, pretty much exactly the same as the other one, except instead of breaking it out by genre, we're breaking it out by language. In the next exercise, I want you to take a minute and actually break out, again, get the average and max duration, but by country and language. So that's going to revisit, a topic we touched on briefly earlier. Think about how you would do that, and I'll see you in the next video. Hey guys, welcome back. Now, hopefully that wasn't too much of a challenge. We know that if we want to break things down by multiple, groups, we just simply add that additional group into our select statement. So we want to break this out by country and by language. And since we have two different fields that we're breaking it out by, we're actually going to group by the ordinal value 1 and 2, right, to represent the columns that we want the breakout by. So we'll say 1, 2. Alternatively, if we wanted to, be a little more verbose, we can type country and language. That works just as well too. So we'll go ahead and run that. And now we have average duration and the maximum movie duration broken out by the country that it was produced in, or the countries that it's associated with, and the language or languages spoken based on that country combination there. So that is a result set. It's pretty straightforward. Again, just adding another dimension and getting more granular with your data. So great job on that one. And see you in the next video. Hey guys, welcome back. All right, in this next video, what I want to do something a little more kind of exact, right? Look for more specific information, in other words, with these queries. So one thing that I want to compare, right, is be able to look at the average duration for movies by country in 2005 specifically, and then compare what the average duration looked like for movies 10 years later. So what I'm going to do is I'm going to actually just go ahead and get rid of language, and since we're not breaking out by language, I'll need to get rid of it as well for my group by category. I'm going to run that just to see what that looks like. Okay, I have average duration by country and max duration here. Now maybe I want to make this a little cleaner and say we're country, right? Not like, and I'm just going to eliminate any movie that has more than one country associated with it. And I know when more than one country is associated with it, when we have a comma in the country. So here we go. Now it's pretty clean. We also have this blank kind of represented by null here. We talked about those a little earlier. And I'll add another condition, and I'll say and country not equal to blanks, right? And we'll go ahead and run that, and we eliminate that. So now it's a little clean. But as I mentioned before, I want to compare the years 2005 and 2015 and the average duration. You know, what did that look like? Did movies get longer? Did movies get shorter? So I'm going to add one more condition, and I'm going to type and year, right? That is one of the fields that we have available to us, as we've seen in the past. And year is equal to 2005. And so like now I have that piece of information. And so I'm going to kind of keep that in mind. Maybe take a look at like the first 3 countries, right? Argentina, Australia, and Austria. And just make a mental note. Okay, average durations like 95 minutes, 95 minutes, and 93 minutes, okay? For those 3 countries. Now I'm going to type 2015, change that up, and go ahead and execute that. And I see that, okay, well, actually I think we're looking at Argentina, right? Argentina is 95, that didn't really change much. Australia like seems to increase by 3 minutes, and Austria by probably about 6 minutes, 7 minutes. I forget what the other one was. I think it was 93 minutes. So yeah, maybe 7 or 8 minutes rather, in terms of movie length. So for at least two countries, it seems that the movie duration actually increased, which is, you know, pretty interesting. Movies get longer over time. Well, I guess they kind of do for some countries, but not by a lot. So so anyways, that's maybe an interesting statistic that you're looking to study, and that's how you can use subsets to, you know, basically compare the results between 2 different sets of information. Now this is an important concept that we did this because I wanted, you know, this was kind of manual, and it did take us recording this information in our minds. So in the next video, we're going to talk about, you know, furthering that along a little more, and how we can do that a little more efficiently. So stay tuned, and thank you for watching. Hey guys, welcome back. Alright, so as I mentioned in the last video, we compared 2005 with 2015. Running 2 queries side by side is, you know, maybe not the most efficient ways to start analyzing data, although it's very kind of neat that we have like the 2 result sets, you know, readily queryable, so that we can kind of compare the 2. But maybe we want to save our results, right? So that we can reference them much more easily in the table. So what I can do, okay, is actually use some of the DDL data definition language statements that we learned in the first course and create this as a table. So we do have, if you recall from our first course, 2 databases available to us. One, our SQL course, and the second one, our Sandbox. So I want us to take note of the Sandbox database name, OscarVal_DDL_Sandbox, and let's go ahead and use that, right? And in the first line of this query, I'm going to say drop table if exists, and I'll say OscarVal_DDL_Sandbox, and so now I'm prefixing with the database name where I'm going to drop a table if it exists, and I'm going to call this you know, stats 2005, my initials, and, you know, like my lucky number, OV12345, right? And this will make it unique to you because you'll know that other students are probably creating and dropping tables as well, so you want to kind of just make it unique to yourself. And then I'll put a semicolon to end the statement. And so what this is doing is actually saying, like, if this table exists in this, if stats 2005 exists in the DDL sandbox, then drop it. And then the next statement is going to add to this select statement here, and we're going to say create table, and we'll just go ahead and highlight this for the sake of just typing less. Control C or Command C, depending on you're on Mac or PC Linux, and we'll say as, right? So now we're going to say create table OscarVal_DDL sandbox stats 2005 OV12345 as, and then this select statement. So now you're saying I want to create this table stats 2005, and I want it to be the results of this query. So in this query, I'm going to change my parameter to 2005 so it lines up with my table name. and I'll go ahead and execute that, hit Control Enter. And now I'm going to switch over to my other database, and now I see that I have this stats 2005 OV1234. Okay, and I'll do the same thing for the 2015 stats, right? Okay, and now just change the year to 2015, execute that as well. And actually for here, I'll have to move over to my SQL course again. It didn't like it because my IMDb table doesn't exist in the other database. So because I didn't specify the database here, it just kind of had this funky error like, hey, the table doesn't exist here. So anyways, that's why I'm switching back. I'm going to run that. Okay, now I'll switch back to my other database where I can write to, create tables, and as you can see, I have my 2005 and 2015 table. Okay, so now what I can do, okay, I can just go ahead and delete all of this, and I'll say select all from stats 2005 OV12345, run that, and I can also do the same thing for my 2015, right? And it's a lot shorter because I saved the results of the subquery here. So like now I'm typing fewer things, and I'm going to pause right there because we're actually going to use you know, these tables that we created to kind of illustrate you know, a couple of other features of SQL, such as joins, later in the course. So I don't want to get ahead of myself, but I do want to introduce you to the fact that you can create tables, at least in this sandbox environment, for usage, and we'll explore that a little later, and just overall kind of make things or life a little easier. So anyways, thank you for watching. We'll cover this further in the course. Right now we'll probably move on to another topic, but at least have this in the back of your mind, in your back pocket, as a tool that you can use to work with data much easier. Thank you for watching, and I'll see you in the next video. Hey guys, welcome back. Alright, in this video we're going to take a break from subqueries and ultimately where we're going to go with these subqueries when it comes to joins, and I want to talk about case statements. And this may be, you know, kind of like a weird place to talk about case statements, but in reality, you know, the final product of a case statement is really kind of consolidated data, or and almost aggregated to some degree, and it really plays into what we end up doing with data, and like the downstream product of our analysis or reporting that we're doing with our data. And I'll go and I'll start by, you know, kind of working through an example. So if we say select title, okay, and duration from our movies table, I can see that I have a lot of information here, right? And it's a lot of numeric information, but it's a lot of raw data to really consume and really make anything out of. But if I was asked the business question, well, can you tell me, you know, if a movie is short, you know, or long, or just really long, how do I quantify that? How do I start labeling these things, right? If I was a human, I'm just looking at the raw data. I have to kind of look at each duration in minutes and make that determination on my own. However, as the data guru that you're becoming, you can actually use case statements, okay? And case statement is you know, written with the keyword case, and it'll actually use an ending keyword called end, and in the middle you're going to have some logical conditions. In this case, we're going to use duration to help us define some labels for the length of the movie. So we'll say case when duration is between, let's say, 0 and 59 minutes, right? Less than an hour. Then we'll call this a short movie. Okay. When the duration is between 60 and 90 minutes, right? An hour and a half, then we'll call that a long movie. Okay. Long movie. And when duration is just greater than 90 minutes, right? Then we'll say, bring a pillow, because it's just going to be a snoozer, right? It's going to be super long, and that's really the the body of a case statement. There is one last kind of condition that you can add, and it's sometimes optional in databases or in query languages. So you can also have a final condition, and this is your default condition. Else, no data available, right? Let's say, for example, we have a null or a blank, and it's just really the database isn't computing anything, so you kind of want to have a catch-all value. This is where the else would come in. Otherwise, you can just leave it to your last condition here, right? So we'll go ahead and run that and take a look at what that is. And another thing that I want to do is I want to alias it, otherwise I get like this really long description value, and we'll call this movie type, I guess. Okay. All right. So like now, what we have here is we have a more descriptive kind of information, right, about the movie, and we have, instead of looking at the minutes to determine if it's a long or short movie, we can convey the information about the movie itself, saying like, oh, it's a long movie, it's a short movie, bring a pillow, this one's 100 minutes long, and so on and so forth. And just by using like the values and starting to determine like or bucket, where these ranges fall and how they should be labeled. So in essence, you're almost kind of even aggregating the data, because truly you can actually use this case statement and apply some aggregation to it. For example, if I'm going to get rid of both title and duration, and maybe just have a count of movies, right? I'll say count 1 as movie count, and then go ahead and group that by my case statement. I'll see that in my database, it counts how many long movies there are versus how many movies that are super long where you bring a pillow, or short movies, etc. Just that give us that kind of high level type of information, aggregated high level information, all with the use of a case statement. So I'm going to stop right there, and I want to challenge you with one exercise, because case statements are pretty straightforward. I want you to use the average vote value, right, in the movies database, and basically we're going to start rating things. We're going to say anything from let's say 0, with a movie rating of 0 to 3.9, we'll call it a bad movie. Okay, anything between 4 and 6.9, we'll call it an okay movie, and anything between 7 and 10, we will call it a good movie. And then you can have whatever you want for your default condition if it doesn't exist, so it'll be your choice. All right, so take a few minutes to kind of piece that together in your mind, and then type it out, and we'll see you in the next video. Hello and welcome back. All right, let's take a look at this case statement. If you found the other example, or the previous case statement example, to be pretty straightforward, I think you're going to find this one to be pretty straightforward as well. So basically, I asked for us to come up with a label, whether a movie is bad, okay, or good, based on the average vote value that it received. So let's go ahead and bring in the movie title, and then we'll start our case statement, right? And so we'll say case, and then we'll have our end, and we'll alias this field as, let's say, movie quality, right? Then we'll go to the chunk, or the meat of our case statement, and we'll say when average vote between, and we said 0 to 3.9 is a bad movie, 0 and 3.9, then bad movie, when average vote between 4 and 6.9, then okay movie, and when average vote between 7 and 10, then good movie. And I actually happened to look at the values earlier and saw that the range really goes between 0 and 10 or something of that nature, but basically capping out at 10. A shorter way to do this, however, though, because I know and I profiled the data that the max value is 10, as I can simply say greater than 6.9 or greater than or equal to 7. Either one is fine. So we'll just say greater than 6.9, then good movie, and that should be good enough. And so there you're kind of writing like less text. Both ways are acceptable. I'll just leave it as that. Then I'll have my catch-all, right, wherever maybe the average vote is missing, and I'll say not scored. Okay. And we're calling this movie quality, and we're grabbing it from our movies database. And I won't put like the limit 100 this time. It's not a lot of records, so you can just query it and you'll be just fine. Query out and be just fine. So we'll run that. And I guess as far as performance wise, just viewing the first 100 rows is a little quicker, so maybe that's a good practice. But nevertheless, we have all our records here, or excuse me, all our results here. The first one, the Cali Gang being an okay movie, this one Inferno being a good movie, and so we have a lot of okay movies based on our rating structure, and then we have a few good movies. And just to kind of validate that, we'll go ahead and bring in the average vote just to kind of see what that looks like and see if our labeling is correct. So we'll run that. Okay, so yeah, 6.1 would be an okay movie, which is true. The value is between 4 and 6.9. This is a good movie because the value is greater than 6.9, right? This is 7.0 in terms of average votes, so it's given a good movie. And so far, so our logic really looks to kind of pan out, in terms of the labeling or the results, the resulting label. Cool. Well, you did a good job there. Hopefully, that was something that was pretty easy to do, and just kind of complete. So keep the case statements in mind. They are going to be very useful. In fact, I think this is probably going to be a statement that you'll frequently use when you start analyzing and aggregating data, and just really kind of comparing data sets, or needing to compare your data at much higher levels, or in a custom way across groups or things that you want to kind of categorize yourself. So case statements are really useful. Hope you had fun learning about case statements as well. We'll go ahead and move on to our next section, our next and final section, which is joins, after this. So thank you, and I'll see you in the next video. Hey guys, as I mentioned, the last section of this course is going to cover joins. So I want to talk a little bit about joins and try to give you the easiest, most straightforward explanation. So if you remember from math class, at some point in time you probably studied set theory. I think having a concept or conceptual understanding of set theory will help you in understanding joins. Now, not all the set operations can be translated into SQL. In reality, there's just two set operations that are applicable or that translate over directly to SQL, and that would be your union and your intersection. You can think of intersections directly as inner joins, and we'll talk about the various types of joins in a bit. But when you say intersection, you can immediately associate it with inner join, and they both start with an I, so that's it can be used kind of as a mnemonic device. Then we have unions. Now, unions aren't considered joins in SQL. Actually, they're just considered a little differently, although they do bring two sets of data together. But that is an important distinction. It's not an actual join. So when I'm talking about joins, table joins, essentially you're going to be given two or more tables anytime you're joining in SQL or using joins in SQL. For simplicity, we'll only be joining or talking about two tables. So basically a join is will result in an overlap, or anytime you execute a join, it'll result in an overlap between table A and B. And really, there can be anywhere from 0 to 100% overlap. So even if you join two tables, it could be that they don't have records in common, so you don't get any results back, depending on the type of join that you're issuing. So that's when I say you can have 0% overlap. That is exactly what it means. Or you can have 100% overlap, where both tables have 100% of the records in common. Tables are used. Are joined using like a common attribute or field, and so what that basically means is, if we think about our movie table, example, or the movie table data set that we've been using, I think there's like a movie title ID or a title ID in the actual table itself. If we had a secondary table with additional, let's say, movie attributes, and just the movie attributes alone, right? Or we can that table would potentially have a title ID, and we would join one table to the other using title ID, and keep us from holding too many redundant columns, so that we don't have to have title and description and actors and so on in a secondary table. It's just more of a common ID, right? So just think of a common attribute between two tables. That's kind of how you're linking the two, and that's how you would join two or compare two sets of information together anyway, right? Using a common attribute. Okay, so the first and most common join that's out there is an inner join. Essentially, inner joins, will return records when there's overlap between two or more tables. So if you conceptualize a table being a circle, one table being a circle, table A, and then table B being another circle, and you were to put these two tables together and just kind of take a look at the overlap that exists between the column, or the attribute, or the column that you're using to join these tables, anywhere again from 0 to 100, that overlap that they have in common, the output of that, the product of that, is your inner join. So the result is just going to be what two tables have in common for inner joins. Your left join, I want you to visualize this. Let's say, for example, again, you're joining on a common attribute in these two tables, and you're basically going to get all the records from table A and any matching records from table B, right? Meaning that not everything in your result set is going to have every single record from table B, just the records that match table A. That is a left join, right? So on the left side of your screen, you have table A, and then you're appending any records that match over from table B. And again, as I said, not all records will be present from table B. That would be considered a left join, and it would be written with that keyword left in its syntax. And we'll see examples later, so don't worry about that. Just kind of concern yourself with conceptualizing joins. Then the final join that we'll be talking about is the right join. And this is really just kind of the opposite of a left join. So instead of returning records from table A, we're actually returning records from B, right, from the right side of this join. So we're going to return all the records from table B, and then the corresponding or matching ones from table A, and that is what our result set is going to consist of. So those are joins in a nutshell. I think it'll become a little more clear once we run through a couple of examples, but I did want to at least kind of have those illustrations in front of you, and there are a lot of illustrations online, much better illustrations, so feel free to Google joins or join diagrams if you're a visual person, and check that out. Okay, well, thank you very much for kind of watching this theoretical introduction to joins. Hopefully these concepts have been pretty straightforward for you. If not, please review them or study them at your leisure, so you can just really solidify what you're doing in SQL with joins. And I'll see you in the next video. Hey guys, welcome back. Alright, let's go ahead and jump into joins. Now for this lesson, I'm going to switch over to my DDL Sandbox Database and use the two tables that I created earlier. Let's say, for example, I want to use all fields from stats 2005, and really want to start off by getting a count of records. Okay. Well, let's go ahead and preview the records actually. So let's just do that. All right, we have Argentina, Australia, Austria in the very beginning. I also want to briefly take a look at my 2015 table and kind of see that in this table, like right off the bat, I see that I have another row that I don't have in my 2005 table, and that's Albania. So that one gets that country gets introduced later down the road. So I'm just going to take a quick count of records between the two tables, and I'll go ahead and run that really quick. And if I want to see that as side by side, I can use my union and then do that as well. Count 1 from stats 2015, and I'll say let's see, rex 05, and then as rex actually as rex, and I'll just add another column so I can be a little more descriptive. 2005 records as a label, right? And do the same thing for this other one. Add a column, and I'll call this 2015 records and use that as my label. So now I'll have records and then what year they pertain to. So it'll just be like kind of a clean table. And like I said, I'm using union here. This is not a join. This is just a function to basically bring two sets of records together. So I'll run that, and I can see that the number of records that I have in 2005 are 65. So I have like 65 countries, or in my 2005 table, and then in my 2015 table, I have 71 countries. So there's clearly a difference between these two tables in terms of sets of information. So let's go ahead, and now that we understand that there's differences in records between those two tables, let's go ahead and start looking at that data. So in this first data set in 2015, I have both. I'm going to alias this as table A, and I'm going to bring back country, and then a.average duration, and I'm going to call this as pre-duration, right? Or I'll just call it early duration. Okay, early average duration. Okay. And that's good. I'm only interested in the average. And what I'm going to do here is I'm going to inner join, right? And I want to compare the stats from 2015, and I'll alias this as label B, and I'm going to join these two tables on country, because that's the one column or field that they have in common. So I'll say on A, from table A equals country, use country to join, and then from table B, use country to join and compare on that. And so we'll be comparing, we'll be having a country to country comparison on average. Now if I want to compare the average on table B, I also need to bring that in. So I'll say b.average duration as later average duration, and we'll go ahead and execute that. And now we have the 2005 average duration and the 2015 average duration. If I want to be a little more clear on that, I can just actually put the year, and I should have probably done this to begin with. Let's see. Sure, why I'm getting that strange character there. Get rid of that. Okay. So now I have average duration in 2005 and average duration in 2015. And now I kind of have a side-by-side comparison of the country's duration, movie duration. And I can get a quick visual check in terms of like, hey, are movie times trending upward? Are they remaining steady, or are they trending downward? And we kind of see that we get a mixed bag. So I'm going to go ahead and stop right there, and just kind of let you think about the inner joins and maybe explore the data a little more. and then we'll come back in our next video. Alrighty, welcome back. So I started off the video with comparing the number of records between 2005 table and the 2015 table, and noted that the 2015 table has a few more records. So I want to take that opportunity and start looking at what the left join the tables would yield. And because our 2015 table has more records, we're actually going to start with that one. So I'm going to start typing a new statement, and basically I'm going to say select all from the 2015 table, and now I'm going to say left join the 2005 table, and again I'm going to alias my tables just so that it makes it easier to abbreviate on certain in the query. So again, I'm joining on country, where a dot country equals table B country. Okay, and what I'm going to bring in from table A is country and I'm going to call it country 2015. Okay, and then I'm also going to bring in from table B country, and I'm going to call this country 2005. Okay, and we'll go ahead and just limit it to we don't actually need to limit it. There are not a lot of records to begin with, so this should run pretty quickly and not take a lot of resources, but we'll run that. And one thing that you can notice here is that we have a nice little join between the two tables, but as we scroll down, one of the things that we start seeing is that for the 2015 table, for a good portion of the countries we had a 2005 counterpart, but we know that we're expecting more tables in the 2015 table. So as we scroll down, we start seeing these associated nulls from the 2005 table. And if we recall, we didn't see Albania in 2005, but we did see it in 2015. And there are some other countries such as Costa Rica, Kazakhstan, Malaysia, Morocco that we don't see in 2005 that we start seeing in 2015. And so what essentially a left join is doing from our kind of theory discussion is that it's bringing all the all the records from the left table, which is your first table, and depending the matching records from the secondary table. So if there are no matching records, you're still going to have the records from the first table appear here, but you won't have records from the second table appear on your right. So that is essentially a left join, and we'll go and stop right there, so you can kind of just maybe experiment and swap the tables around and start seeing what kind of results you see there. See if you see if you identify any countries that are in 2005, but don't show up in 2015. And so just kind of play around with a left join so you can get comfortable with it, and we'll continue in our next lesson with right joins. Hey guys, welcome back. Alright, so the next join that I want to talk about is a right join, and as we talked about, or as we looked at the left join, we saw that we were able to get more countries right from the 2015 table than we were in the 2005 table, at least when we executed this left join. So what happens if we go ahead and try a right join in that case? And now if you remember, a right join will bring back all the records in this table where they don't necessarily exist in the left table, right, in the first table. So one thing that I'm going to do real quickly though is I'm going to say run my left join again, and then put a condition here where b dot country is null. Okay, and let's just go ahead and run that really quick, and that's just going to give us the 13 records where in 2005 there isn't a country. So since I'm going to do a right join this time, I'm going to say where a country, like country from table A, is null, right? So now I'm going to change this to a right join, and that way we'll see the results pretty quickly in terms of like, are there countries in table B in 2005 that aren't in 2015? So let's go and highlight that, and run it. All right, here we go. It does seem that in 2005 we do have some countries, excuse me, where we have movies for that we don't have in 2015. So what we did here is we said, select from stats in 2015 from the table in 2015, right join or otherwise include all records from table B in 2005, right? Based on country, and now but limit it to records where there is no record, where country in table A is null, right? So here we are, we have 7 records. So it turns out there are movies in 2005 for countries that just that don't exist for 2015. I'll go ahead and cancel out that that setting the country to null, and kind of just see what that looks like. I mean, the results are going to look a little similar, right? We're going to see joins where records for both countries exist in both years until we scroll all the way down, where we start seeing nulls again here on the left side for the 2015 column versus 2005. Okay, so that's a right join in a nutshell. Go ahead and experiment, a little more just to kind of understand what the difference is. If you have any doubts or just still kind of wrapping your head around it, or execute both the left join and the right join, and then just kind of compare the two. The data sets are pretty small, so it shouldn't be too difficult, even if you wanted to copy these records into a spreadsheet and just kind of compare them side by side. Alright, well, thanks for watching. In the next couple of videos, we're just going to have exercises that we're going to run through pretty quickly so that we can get you a good foundation in joins, and you'll be absolutely ready for your data analysis and reporting and analytics type of roles. Alright, thanks, and thanks for watching the video, and see you in the next video. Alright, welcome back. Let's go ahead and use our two tables, the 2005 and 2015 movie stats, and examine duration. So for this exercise, we want to compare movie duration between 2005 and 2015. If you want to pause the video right now and just try running the exercise or doing the exercise on your own. If not, we'll just go ahead and get started. So I already have 2 tables set up, right, conveniently, stats 2005 and then stats 2015 that give me the average and the max movie duration per country. So I'm going to use those movies. I'm going to say select all from just for right now from stats 2005, and I'm going to type an inner join. I'm going to use an inner join, excuse me, to join against stats 2015, and I'm labeling each table or aliasing each table, excuse me, with A and B respectively. And this way I'm just going to run that and kind of take a look at all the records that I have. So in the first table, I do have some columns that have very similar naming convention, so I want to go ahead and actually start aliasing these columns, right? But I want to look at my data too and see if I have what I need in order to answer the question comparing movie duration between 2005 and 2015. My question actually is, did movies get longer after 10 years, right? So I want to examine that, and I'm going to have to examine that at a higher level than what I have here, but the main components are here: average duration here for 2005 and average duration for 2015. And again, we're joining on country, so country is consistent in both columns. So what I'm going to do is I'm going to take country from table A, I'm going to take average duration from table A, and I'll call it, I'll alias it duration 05 just for brevity, and then I'll do the same for 2015, and I'll call that duration 15, and then I'll go ahead and run that. Okay, and now I can see that I have both columns. So what I'm going to do next, I'm actually going to use a case statement. So I'm going to say case when a.avg duration greater than b.avg duration, then, well, I'll just do it in the same line, then shorter, then when a.avg duration for a is less than or equal to, excuse me, b.average duration, then we'll say then movies are longer, right? So if they're longer in 2015, meaning like if the average duration 2015 is, you know, basically greater than or equal to the duration 2005, we're going to say the movies are longer. Else, right, this is when they're equal, then we'll say else same. And now we have, right, we'll go ahead and end this column, and we'll say duration category, and we'll go ahead and run that. And now we have a label. Okay, so now we have a label that basically says longer and shorter. So what we can do, right, instead of looking at each individual one and, you know, computing the length, right, first of all, let's look at our logic. You know, it's saying 95.667 is less than 95.6, I'm sorry, hold on a second, let's see, did we do this correctly? Yeah, we did. Okay, I'm sorry. In 2005, the movie was 95.67 minutes long. In 15, in Argentina, it's 95.62 minutes long. So that would make the movies in 2015 shorter on average in Argentina. Here we have 98 versus 95 minutes, which would make the movie longer. That's true. 101 versus 93 minutes longer and true. So our logic is correct. And we have these categories. And as I was saying, we can look at these individual one by one and kind of either do the arithmetic or look at the label, but that would just be very time consuming. So what we're going to do now is we're actually going to utilize subqueries, right? So we're going to say select and then all from, and I'm just doing all, but we really don't, we're really going to change it up from all, but I just kind of want to test my results and then look at my, and look at this as a table and then hit enter, okay? And basically what I'm saying is, like, when I put this in a subquery, right, select all from and then parentheses, enclose my query in a parentheses, I'm going to have this result set nice and neat. But now I'm going to go ahead and actually look at, or count, excuse me, by my duration category. So I'll say select duration category and then count 1 as movie count. And then we'll go to the bottom of the query and we'll say group by 1. And now we'll just do a much smaller count on the overall shorter versus longer, right? And so like now we see that we have you know, longer movies in 31 countries and shorter movies in 27 countries. So, you know, in reality, when we're kind of looking at that at a high level, you know, 31 countries produce longer movies after 15 years. We don't really necessarily know how long. We can do the math there. 27 produce shorter movies. So, you know what? More than likely, movies didn't really get longer overall. It's kind of just a flip of a coin. And if we look at the data a little closer, we can probably see that, you know, there's not a lot of difference. So we could, you know, dive into this a little deeper and then start doing some computations in terms of like, well, how much longer and stuff like that to quantify it. But overall, what the data says is like, well, not really. It's kind of a mixed bag. You know, it's like kind of half and half. So chances are they really didn't get much longer in the span of 10 years. All right. Well, thank you very much for watching. I hope that exercise was pretty easy. You got to use your subqueries, case statements, and of course aggregation. And which is very similar to what you'd be doing in the real world. So thanks for watching, and I'll see you in the next video. Hello and welcome back. All right, in this next exercise, the request is to evaluate you know, the years between 2000 and 2015 and determine you know, on a year-by-year comparison which country had funnier movies between France and the US. And we're going to use average vote as our measure of funniness, and we're also going to focus on the genre of comedy. In order to do that, though, we did start off in our Oscar Val DDL Sandbox database, but we're going to switch right over to SQL course. And the reason we're doing that is because we don't have pre-aggregated information of this type. We can always create that in our sandbox and do it a slightly different way, but for this exercise we're going to go ahead and use subqueries. So in order to do that all in one kind of query, let's go ahead and switch over to the SQL course database. So once you switch over, you should see these three tables and you're there. The first thing that I want to do is I want to just start computing this information, right? I know that I want to do a year-by-year comparison between 2000 and 2015, and then look at the average vote. So I'm going to say select year, and if I expand my columns, I see I have year and I have average vote. So I'm going to say average vote, and it's pretty unusual to take an average of an average, but for this purpose it's quite fine. So from IMDb movies, and then I'll start using my where clause to start refining this information, where genre equals comedy and country equals USA and year between 2000 and 2015. So I want to run that really quickly, and of course let's not forget the group by clause, group by year, or you can say group by one, your choice. And now for the USA, for comedy movies, I have an annual average vote breakout for those comedy movies, right? And I want to do the exact same thing for France, so I'm going to copy and paste my query and then do this for France. And all I have to do is just actually change the country that I'm filtering for, and I run that, and then I see that I have a different result set, right? Now I want to compare like these two kind of side by side. So in order to do that, I can actually use subqueries, right? You probably guessed that already. So I'm going to start kind of pre-indenting these queries here. And as you recall, in order to use a subquery, you have to enclose your queries in parentheses. So I'm going to do that just kind of ahead of time right here. Start enclosing these as in the parentheses. And I know that I have to give my queries an alias, so I'm going to alias this with U because it's for the USA, and I'm going to alias this subquery after I enclose it with F for France. Okay, so like now I have these kind of subqueries, right, in these parentheses, and they're really serving as tables. So I'm going to start treating them as tables, and I'm going to say select all from, and now I have from subquery U right here, right, or table U that's based on the subquery. And now I'm going to use my inner join statement. So inner join, and I have this next subquery, which is the France result set. Inner join, table F or subquery F on, and then U dot country, right, because we have, not country, year in this case, because we have year in common, and we're going to do a year by year comparison. U for United States year equals F dot year for France year, and now we're just going to go ahead and run that. Okay, now we see that we're presented with a side-by-side annual comparison between two tables. If I want to kind of get a little more descriptive on my column, because here I see that they're the same name, I can actually just change average vote average vote to average vote USA, and then average vote to average vote France, and then just rerun that. And now I have a very cleanly labeled or distinctly labeled USA average vote versus France vote. So I really don't need 2 years showing up, so I can just choose to keep 1 year. I'll go with my left table and keep the year there. I know it's inner join results, so it doesn't make a difference, but I'll just use it from the first table. So I'll say u.year, u.average vote USA, f.average vote France, and then I have a cleaner data set. And visually I can kind of see here that France, for the most part, won the vote in terms of comedy, right, when compared to the USA, year over year. If I had, let's say, hundreds of, or maybe just too many years to kind of visually inspect this, I can go ahead and write a case statement. So I'll say case when u.average vote USA greater than f.average vote France then USA, otherwise or else France, and we'll go ahead and end as, let's see, funny country. We'll just alias that funny country, and we'll also add a count in here. So count, and I like to use distinct, right? When there's a possibility of being, maybe duplicate records here. It doesn't really make a difference, but if you want like unique counts, I always like to use distinct. And again, select a year column, right? So this one we're using from table U or subquery U. And let's go ahead and get rid of these, first fields, or these fields that we brought in. And now we're gonna go ahead and group our results, right? Because it's an aggregate query, group by one, right? We're grouping by not a field, actually we're grouping by a derived field, or this case statement here, right? That we're aliasing as funny country. So we're grouping by that case statement. And let's go ahead and run that. And now we see very clearly, right, that we have France with 15 years where their average votes were greater than the average votes for USA in the comedy category. And whereas the USA just has 1 year. So, we can say based on this data, France is kind of a funnier country in terms of movies. So that's actually caught me by surprise, because I felt, or at least I thought, that the USA would just come out on top given all the movies that it comes out with. But that's definitely interesting to see right there. So thank you very much for watching. I hope that was a pretty kind of pretty interesting. First of all, something new that you piece together using subqueries. So you know that you can do this multiple ways, creating tables that are pre-aggregated and then joining them, or just on the fly using subqueries for that purpose. So thank you very much for watching, and I'll see you in the next video. Hey guys, welcome back to the last video of the course. In order to keep this under 2 hours, I'm going to try to go through this last example pretty quickly. So let's get to it. The question that I have is, what % of good, okay, bad movies do we have in India, right? So do we have for India, rather? And if we recall, we had an earlier example where we actually used the case statement to derive the movie quality, and we're going to use this again. So let's go ahead and use our case statement to assess the movie quality, whether it's bad, okay, or good, and then we'll do a count as movie count. Okay, and from our movies table, where country equals India, and then we'll go ahead and also group by one, since we are doing an aggregate here, and we have an attribute or a field that we need to group by. So let's go and highlight that, run it. And then we see here that we have a count of bad, good, and okay movies, but we want to know what the percentage of each is, right? So we're actually going to introduce another query, and we can actually just select this query again, and instead of grouping, we're just going to get the straight count, because one way to get this information is to actually treat this as the numerator and then just get the denominator, and then we'll get a % of total, right? So in order to get that denominator, we need to get a count of all movies in India. So if we run this query here, we see that we have 5,000 plus movies. So now what I want to do is I want to go ahead and start using my subquery magic. I'm going to tab that over so I can get that indentation. It can look a little cleaner and make this into a subquery. So I'm going to call this movie count, right? And so I'll say select all from, and then this is my subquery MC, which I'm aliasing as movie count. And I'm also going to make this other query into a subquery. Now, if you notice the difference between the two, one had, the movie count and then the movie quality, and this one has a total movie count. I'm just going to say total. Should I just call it total movies for the sake of being shorter? So you don't necessarily really, so you don't really have a column to join on, simply because just the the values are different and they just represent different things, right? Where one is a total, the other one is a breakout. But I am going to use this, and I want to do what's called a Cartesian join. So I'm going to say inner join on this result set, and we'll alias this, and we'll call this TM for total movies, and we're going to join on the conditions of 1 equals 1. That means it's just basically true. So it's going to take all the records from this query, which is just the 5,540, and all the records from this, and then just bring them together, right? Without any condition or any attribute column to be joined on. So let's just go ahead and run that, and we see that we have again our first result set, and then repeated on every row is our totals. So now that we have that information, we can start beginning and deriving our what we need to know for for the percent of total. So we can actually keep this as all comma, and then we'll say MC dot movie count divided by, and then we called this one here TM dot total movies, and we'll alias this as percent total, and we'll run that. And so now we have our percent of bad movies, good movies, and okay movies, and we can see that the percent of bad movies is very minuscule. It's 7% or almost 8%, and we have good movies is as many as 38%. So it's almost half of the movies are rated as good movies. So that's definitely interesting facts. You can compare different countries to each other by doing the same set of joins and just kind of stringing them together. So but anyways, at the very minimum though, we did do something very new, very cool, is we used subqueries as joins as we've done before, but more importantly we introduced this concept of the Cartesian join, and then we used some arithmetic in order to derive some total or some values that we're interested in, some percentages, so inline arithmetic in order to do that. And of course the usage of case statements to get high level quantitative or qualitative information on our quantitative data. All right, well, great, thank you very much. I wish you a blessed year, and I appreciate you completing this course. All the best to you in your journey, in your analytics journey. Thank you, and have a blessed year.